For Lesson 9, let's start talking about negative numbers and how they fall into the scheme of things that we're doing with the algebraic expressions and equations. Integers is a term I want you to know, and it includes positive numbers. It also includes negative numbers. And it also includes the number 0. So positives, negatives, zeros, those are integers. So you may hear that term, and I want you to know what it means. The negative numbers are the ones that are, you can think of as this, below, lower than, smaller than 0. Those are negatives. Now, on a number line, like I've got for you here below, you'll see that the negative numbers are to the left of 0, and if you were looking at it on a vertical line, you would see that the numbers are going to be below 0. You can think of you can think of below sea level. You can think of a temperature below 0, and that is some of the ways that we use negative numbers. Let's look at these signs in our examples. We have a greater than sign and a less than sign that tell us, which numbers are bigger and which ones are smaller. And they want us to insert either less than or greater than between each of the pairs of integers to make it a true statement. Now, what we have to remember is that in the less than or greater than sign, the smaller pointy end always points to the small number. The larger end of the sign always to the larger number. So if you can't remember whether it's less than or greater than, you don't have to worry. Just put the point toward the small number, the large end toward the big number, and you'll be okay. Example 1 says -8 and 0. Well, 0 is always bigger than any negative number. You can look at your number line and tell the numbers to the right on our number line are always larger, and 0, of course, is larger than any negative. So we would point our small sign toward the -8, and we would read it, -8 is less than 0. Example 2, I have -7 and -5. Well, when you're dealing with two negative numbers, it seems a little backwards. -7 seems like it should be bigger, and it would be bigger if it was a +7 and a +5. But in this case, negatives are sort of the larger the negative seems to be, the smaller the number gets. In other words, the further to the left you go, the smaller your number is getting. And -7 is further left than -5. Example 3 says 1 and -7. And of course, any positive number is bigger than any negative number. And example 4 tells us the same thing, 13, -13. Once again, any positive number is bigger than any negative number. Now, absolute value is really a distance measurement. It is the distance from 0. And because of this, it is always a positive number. So when we're dealing with absolute value, you'll see it's 2 bars on the side of a number. Example 5, we have the absolute value of 6. Well, how far is 6 from 0? Well, it's 6, positive 6. Just because the absolute value inside, or 6 inside it was positive, don't change the sign. You just always make it a positive number. When you get rid of absolute value signs, what you're really doing is resolving the absolute value. Example 6 says absolute value of -8. And of course, that would be positive 8. How far is -8 from 0? Well, 8 spaces. Just like you would never say, I'm -43 feet from that building. You would, just because you're behind the building, you're not -43 feet, you're a positive 43 feet. So think of absolute value as always being positive. Number 7, this is a little different. This negative sign is not inside those absolute value signs. When I resolve the absolute value of 3, I get 3. And then all I do is I keep that negative that was out front. So my answer to negative, the absolute value of 3, is -3. Example 8 is sort of the same thing. First, I'm going to resolve what's inside absolute value. Absolute value of -2 is a positive 2. But this negative that's out front, I can't forget about it. So my answer to number 8 is -2. And number 9 is not absolute value. It's really multiplication. When we have two negatives next to each other and there's a parentheses in between, it's saying, it's just like multiplying a negative times a negative. If you see two negatives together, you can turn them into a positive. You can say a minus a -2 is really +2. Example 10, let's resolve what's inside absolute value first. Absolute value of negative 12 is 12. And then we need to just keep the negative sign that is stuck out front. And the second one, I've got negative 12. That's really going to be a positive 12. Now, which one of these is larger? Let's put a sign between the two of them that shows which one is smaller and which one is larger. And of course, the negative 12 would be smaller than the positive 12.